You're welcome. Thanks for coming. The topic for now is superpowers of deployment tool. First, two sentences about myself. The name is Jöran Vinzenz. I'm working for a company in Germany called Zipgate, which is a voice over IP carrier and an MVNO. And I started there about 6 years ago. And when I started there, our deployment process looked pretty much like this. This is a tool called ClusterSSH, and you have the possibility to have one input command line and several servers where you can do actually the same command at the same time. And here we see some servers here. It's about 40, which is a third of our Asterisk servers we have in production. And you can pretty much see nothing. This is a major fault in that. So if you run a command or you copy a file, you more or less hope that it's worked. This is about how it looks 4 years ago and earlier. And in terms of what we have for deployment, it was a pretty much manual deployment. We had sprint cycle of 2 weeks, and at the end of every sprint we met in the morning at 7:30 with a bunch of people in the company and had some breakfast, and then we started to basically shut down our company and deploy everything and test everything. And it occupied about the entire company for an entire day to get everything to staging, to test it, to get it to deployment, test it. And in this time where we deployed our systems, the front end for the customer, the login for the customer, and everything was down. Except the telephony part, everything was not accessible for the customers. And after we deployed everything, we had to manually test everything. And since we have lots of work done in the 2 weeks before, we had a lot to test. And we don't know if we find any fault, if it's based on the one change or another change. So we basically had to dig deep into every failure we found or every fault we found. And as manual processes, usually we had the same, we forgot something. At every rollout we forgot something. And we had monitoring tools to remind us to have the same config on each server. For this we had a global variable in the Asterisk core, in the dial plan, which includes the last commit ID of our Git repository. And through our Nagios check, we asked the Asterisk for this commit ID. So when we changed everything and we make a dial plan reload, the monitoring knew which was the actual config state which was running on the server. And then we saw, oh God, we forgot this gateway, we forgot that gateway, we forgot our voicemails part, we forgot this. And it was pretty much a nightmare. And since it was manual and we had to do manual steps in the production systems and some other manual things in the staging productions, we had different code bases for development and production. It was never the same. So what we tested was not actually that what we have in production later on. And then we thought, due to the company's rises in people and our customer rises, which is pretty good, but it's hard to have these manual deployment steps with a limited bunch of guys to do it every morning or every 2 weeks morning. So we needed to change something, and then there was Ansible. Ansible is a deployment tool we used, and we started with the front-end website, which is pretty much easy because it's just some PHP, JavaScript, something like that. And after that, we started with the business logic, which is in Java. So we have containerized stuff we had to copy from A to B and then restart the service, and then the front-end websites. And after that, we concentrated on the VoIP part. This is what I'm telling later on. And in the meantime, we even had our network infrastructure included to the Ansible environment. So if we have a new switch, we can just deploy it like everything else. The initial idea why we did that was, in the first place, to have the possibility of continuous deployment. So every change we do in the components should go to production directly. Then you don't need to know the setup, which is an essential part for hiring new people. And if they are new, they can put things into production without knowing which server contains what system, which server does which database connection, and so on. You don't need to know that all just to deploy something. Then enable everybody instead of the stakeholders. So this means not always the same people meet in the morning deploying the systems, but everybody at any time can deploy new software. And for sure, automatic tests were an essential part of that we don't have to spend an entire day testing every single thing we do. And in terms of secure rollout, this is important if we have a failure or we discover failure during the rollout, during putting things into production or in development. We want to make sure that the systems are going to stay online, and if something breaks entirely, then we have to roll back automatically. This is a general idea what we want to have. We have several components involved in this deployment process, which is in the first place GitHub. It's a GitHub Enterprise version. Then we have Jenkins to manage all the jobs we have to do. Then Ansible, which actually does the magic. And we use Debian for our operating systems. And so we use the Debian packet management to handle all the code we have. So how does it work? In the first place, there are some bunch of people coding and pushing things to GitHub. And from there on, there's an automatic way or automatic deployment where the GitHub triggers Jenkins if there's something new. And Jenkins pushes the Debian build environment to build a Debian package from the code we have. And after this package is uploaded to the Debian packet management, Jenkins triggers Ansible to do the magic on the server itself. Ansible, what Ansible does in basic is check what is installed at the moment, then get the new package from the Debian system management, install the new package, install the config, reload the system, do some tests, and if anything goes wrong, roll back and ensure the system is working again. So this is how it works. So, should. Ansible is a powerful tool, really, and it gives lots of opportunity in terms of configuring a daemon or building up a configuration for a daemon. And therefore, you have the possibility to use templates and files. So templates, it's basically a config where you have some variables in there. And then we have this environment data. So this is what we have to put in there, which variable for which server has which value. And all this together combined gives a valid configuration for a server. So in terms of voice over IP, you can't compare an asterisk with an Apache. So Apache you can restart, you don't care about, then maybe the getting the pages a bit faster or slower. But VoIP, you can't restart an asterisk during daytime. So we have some things to think about when we're speaking of automatic deployment way for voice services. First is, of course, restarting. Then we have to deal with real-time communication. We have ongoing sessions we don't want to lose. We have retransmit if we are offline. We have UDP and TCP connection on the server. We have some load balancer in between. We can't just put a system out of there by tearing it down or something. And then, I think everybody knows of you, we have big config files. And of course, we have lots of different components. If we think about Kamailio, OpenSIPs, Asterisk, K8, RTP engine, whatever, they are all configured in a different way. We have 4 major components, which is Kamailio, Asterisk, K8, and the RTP engine, and all of them are configured in a different way. So you have to deal with all this and push all these different configuration in a uniform way that you can deploy it in one process type. I can tell what we did. The first, we did several iterations to be where we are now. We have lots of different systems, and we have done lots of mistakes during that process. And we're still living with that mistakes because we don't want to afford to invent our deployment process new for the old systems. what I'm talking about now is what we know now, which is the best and which works for us the best. That might be different on somebody else's deployment, but we know install the code via Debian packet management and create config by Ansible using host and group specific variables. So in terms of what is code and what is config, it's not that easy. I would say code like config, like extension conf or the Kamailio config, the root part of that, is more config, it's more code than config. So it's not the standard ini file config key value pair, whatever. So the AMI, AGI, ARI scripts you have, or daemons you have, or whatever you use for that, this is definitely code. This is not a config. They have a config maybe for house the database credentials for the development or the production environment. So these are different in what you have to put in there to work, but the code itself is code. No argue about that. Why do we want to divide that? If you put the code in a Debian package or in a Red Hat package management, whatever, and you install the new version, the packet management knows the old package, so you can just install the old version and you have the old code again. You don't have to push the code to the server. You don't have to restart blah, blah, blah and make some stuff you did before. You just have to install the old package and you have the old server again. Then keep the config simple is one major. If you look at the Kamailio config, you have easily several thousand lines of code in there, which is called config, which is not config. But if you put just the config part, the key value pairs and the mod params, for example, out in a separate file, you have an easy config. You can just have a look at that, where you have some variables which are depending on the stage you are. Then you can keep track of the logic changes you make in the code. So if you change the IP address, you have a change in the code so far. If you divide that and put the config beside, you have a change in the code. You know that you have a change in the code, and you can track that over time. And using the same code or the specific same file for everything, because it's in a file and there is no variable in there, it makes the development production equals the production environment. So if you find something in development or you think it's working in development, it pretty much works in production as well. So how does it look? We have in Kamailio config view, we have this config part on the left side where we have the standard ini file config and some mod params and some listen UDP stuff. On the right side, we have the config, the code part. It's now Kamailio config code part, but it looks like code. So we have an if statement, we have maybe some loops, whatever. So you can just divide that by that. The root definition is code, and the config is config. But there is something odd in the Kamailio config. You can have something like this. You can check on source IP addresses. So this might be different on whether you are in development or production environment. So you have to have this as a variable. No problem. You can pull the IP address in this case out of the root part, put it in a variable, in a global variable, and check for the global variable. So it makes the lower part, the root part, is the same, exactly the same file for development and production. Just the IP address string changes depending on whether you're in development or production. So how does it all come together? We have the Debian packet management containing whatever Kamailio config, which is the actual root part. So there is all the logic happens in the Kamailio. And then you have the Ansible part where you have the header files and maybe some system config files. Maybe you have some DB entries you do during the rollout. And all that together makes a running config. Just one of them makes no running config, at least in our case. So what we have in the Debian packet, we have maybe the include file for the config header file, and then we have the root description, and in the config, which comes from Ansible, we have the config part. So here you can have maybe debug different in production and development. For sure, you have other listen IP addresses depending on whether you have more systems for one job. You can just have a template for that. So, speaking, what can you do and how we did it? How does it work in Ansible view? In Ansible you have these playbooks, which is a definition on what servers should be done what job. And then you have the inventory on the other side, which groups the different hosts you have to certain groups, and then you can have variables based on the host or the group you are working on. And it works in this way. During the playbook role, you have different facts or different sets of variables depending on the group and the host you are working on. And if you change the host because you have another host, maybe the listen IPs which are bind to the host specifics are changing as well. So here you have maybe a listen IP address for asterisk, for database connection, whatever. Then the most easiest task in Ansible is copy. It just takes a local file and put it remote on the server. You can say, we have a source file named string of the host name, which comes from the Ansible host environment. And we want to push that to the server we are working on in etc asterisk zipconf. And the owner should be asterisk, and we have mode and blah, blah, blah. So this copies the file, and during the copy, it changes the file name and puts where it should be. Now, it's odd if you have more than one asterisk because you have lots of different files with hostname underlined zipconf with maybe more or less the same content. You can use templates instead. For example, here we have the zipconf. I know it's deprecated, but does the job. We have, in the general part, we have bind port and bind address. Bind port, I would say, is group specific. So we want to have zip always listen on one port in the default 5060. And we have this bind address, which is pretty much host specific. And during the template is installed on the server, Ansible grabs data from the facts it has about the group and the server and puts in the right variables you have. This is a sample of what you have. Then you have a service port 5060 in the group variables of the group asterisk, and you have a service IP depending on the host you are working on. So you might be on the host 1, and then the first one is correct. Your next host, then another IP address is correct. And so the template gets installed on the server host specific. Then there are some possibilities you can do with the asterisk. First is you can use command to control the asterisk, which is pretty much everything we can do on the shell command. Reload the asterisk, or reload the dial plan, reload zip, or if you need to restart it for whatever reason, you can say just core start when convenient. But this is everything you can do on the command line with the asterisk you can do with Ansible as well. So you don't have to SSH to a server, make your asterisk zip reload and go back again. You can just put that in the task for the playbook, and then Ansible does it. Then there's some side task we usually have to make. Normally we have, if you look just on the server, you have copy some files, maybe install a template, maybe restart the daemon and look if it's working and check if the work is rolling, something like that. But then you have some side task. Maybe you want to entry an DB entry for the host on another system. So you have to jump during the playbook on another server, which is not the server you are working on initially, but maybe a database to insert something. And then you can use delegate to do tasks on other hosts for this particular server. This is, you can use here, I took the sample, set the dispatcher set of the Kamailio to deactivate, so it does not get new calls. This might be the first step in rolling config to an asterisk. So you jump to your load balancer, you deactivate it from the load balancer, then you have no new calls on your asterisk. You have just to deal with the existing calls, which makes some things pretty much easier. For example, restart an AGI or restart an AMI. When there are no new calls, it's pretty it's easier than you have to deal with constantly incoming calls, and maybe you tear down your fast AGI or ARI service, and then the call breaks. You don't want to do that, so you can just get it out of the load balancer dispatcher, and then you can do stuff. And at the end, don't forget to get it in again. Then you put all out, I would say. So that sounds nice, but we spent half a year with 4 people to introduce all that stuff with GitHub, with Ansible, with all the stuff. You don't need that. You can just automate all the tasks you make now by hand. So it's pretty much start where you are. As I said, you don't need to have all these tools. All you need is to install Ansible, apt-get install Ansible, and then you can just fire the Ansible manually. And then you have, during Ansible is running, you can make lunch break, just watch the log going by, do other stuff, whatever. You don't have to deal with it in this way you did before. How it could look like. So before we started, we jumped to a server with SSH. We pull the config and the code from a GitHub. We copy some file. We trigger some scripts, and we restart or reload the daemon. This is pretty much what we did before we moved to Ansible. And this is how it might look like. First, in this playbook, we make sure the config in the temporary file is not there. Then we grab or we clone the config from the GitHub repository, and then we start any script which might install something, restart something, whatever. This might be exactly the same what you did or what you do so far. You don't have to do it manually. And after that, you just delete the config, just what you grabbed from the GitHub or Git. And after that, you restart a daemon, or you make this command asterisk reload, whatever. And then you're done. You don't have to do that by your own hands. Things you can do with Ansible. You can do a lot of stuff. I just have some samples what you might do here. In this case, we're creating a new database user, or update the database with the user, or just ensure the user is present in the database. Therefore, we use this MySQL user command or task in Ansible and give which DB user, which password, from which server you want to connect. And we delegate this to our database. From there on, we have a database user, but we don't know if it's working. So we go to our initial server again, and we just make and select 1 to our MySQL database to see if it's working. If I get a 1 back from the database, I know I have no problems with connection. I have no problems with firewall. I have fit everything I need. This select 1 is the most simple what you can do on an SQL database. You can do much more stuff. And so you can read the table, or you can do stuff on the database. And the outcome of this select 1 is stored in this case to a variable inside of Ansible called db check result. And in the next step, we check if we get back a 1 from our select 1. And if we don't do that, we fail. So we stop the entire rollout. And then we can fix the problem, maybe open a port in the firewall, check the writes in the MySQL database. Then we can look manually what's happening. But when the task is gone, or the task is green, or just it's working, then we know exactly the user and the password and the MySQL connection is working. So we ensure that every time we roll out, you can do that thousands of times, and you guaranteed be sure it's working. Then a side task would be inserting the gateway into a dispatcher set, or make sure the gateway is in the dispatcher set. So this is, it's hard to read, it's an insert ignore into dispatcher variables for the MySQL database. So this is what we need to do, or we needed manually to do in order to get something into a database. And after that, we reload the dispatcher that the Kamailio knows the new database values. We can do that just by task. We don't have to do it manually. And after that, we can check the dispatcher set. So in best case, you wait a second, and then you can fire this Kamailio command dispatcher list. Then you get a list of the entire dispatcher set. Then we thought grep might do the work. Use for this line for the specific gateway we just entered, and then we grab for the flags. And in the flags we see if it's active or passive, or if it's deactivated or whatever. And on this output, we can choose whether it's working or not. And if, in this case, we are searching for an IP, which is inactive probing. And if this inactive probing is in the data or in the Kamailio dispatcher set, we fail because for any reason we can't get from the dispatcher to the gateway. And this ensures that when we finished with the playbook, the gateway does get traffic. And if not, we have to check what's going on. We have done a lot and we have learned a lot. And really, the only thing I recommend is avoid non-testable stuff, which includes extension conf and Kamailio conf. For extension conf, put everything into Java, into whatever script language you want to do. But the last 3 times we made changes on the extensions conf in Zipgate, we stopped the company because of any stupid failure, because of any memory leak we produced, because of any whatever. If you have tests for everything, unit tests for everything, you can do test-driven development, which ensures quality of your code. And the extension conf, to be honest, it is code, what we do there. Same for Kamailio config. You have the possibility to use Lua instead of the Kamailio config. It's a little bit decrease of speed, but it's pretty much everything you can do with the Kamailio config. So use ARI, AGI, AMI for the tasks you do in the extension conf. They are so powerful, you don't need to use the extensions conf, at least not all the full functionality you want to have. And for the Kamailio or for OpenZips, use Lua instead. And then another thing which is good to have makes things restart safe. So we learned that when we restart the stateful Kamailio, which saves the location, it's bad to restart it. So write things into hash tables and make the hash tables push things into a database. Save location into a database. If you have more than one service, use this DMQ module to let the other know what the state of this one is. Avoid dialog tracking and avoid stateful instances of Kamailio. So you can restart it just in time and you don't lose anything. So coming to an end, I have some numbers and charts and so on. Our core routing engine, which tells the system which calls go to what carrier outside and checks if the carrier is online. This is written by us. We have in this peak week, we have 33 commits a week. We have 8 commits a day in peak. And every single commit is going to production. So if something fails, we definitely know, okay, this must be the last commit where it fails and where we have to search for the failure. And in the meantime, it changed that the most routing engine changes we have are done by our customer support, because they are calling with the customer and the customer says, okay, I can't reach this number, and if this is counting and maybe we can put that on maybe country is not reachable through this one carrier, or we have bad voice quality, then they can change the carrier. For sure, we have a controller looking over that. This is not spreading anywhere, but the most changes are done directly from the trigger of the customer. For our asterisk configuration, it looks a little bit different because we don't have so many changes in the asterisk config. In this one peak week, we have 21 commits in 1 week, 9 commits a day, and not nearly every single commit goes to production, but it's much more than every 2 weeks. So I would say every day we have a change, we go once to production. Hopefully not in Friday afternoon, but you never know. In terms of how fast it is, we have 11 machines running 86 instances of Kamail-EO in production, and the Ansible installs all of these 86 instances in 11 minutes. If I compare this with my hands, I'm not nearly near that. I would take half a day to ensure everything is working, everything is fine, and then I had a bad feeling. So just think about that. We have on these 11 machines, Ansible takes 1,111 tasks performed to ensure it's installed, it's up to date, and it's running. I wouldn't do 1,111 tasks in 11 minutes. So for our asterisk configuration, we have 47 machines. These are the one group of the asterisk. We have another group which takes much longer, but 47 machines, the config is deployed in 15 minutes. And after that, I know exactly every asterisk has connection to the load balancer, has connection to the proxy, has connection to the database, the correct version is installed, and the version is working, and the asterisk has calls and is up and running and so on. I can't do that in 15 minutes. If you want to have more information, here are some links. There's a colleague of mine who talked a little bit more about Ansible, what is possible. Then you can have the first link. I put some Ansible and Debian package samples in our public GitHub. This is the second link. You can just go there. There you can download all the code, do whatever you want with that. I missed the order. The first one is we have a blog post from our administrators for how we use Ansible for the network stuff. We have Juniper network stuff, and we push config with Ansible there. It's pretty powerful and I guess something new. If you need more information, or you can always send me an IM on LinkedIn or drop me a message on Twitter, whatever. Are there any questions? I think you have a mic. There's one.
Mike, coming to you now.
Excuse me? Yeah, sure. Yeah.
Hi. So you said that you are using Debian packages for Kamail-EO.cfg and extensions.conf, which you deem to be code instead of that. Yeah. We use Debian packaging too, and what we found is that Debian packaging sees, it's an etc and it's a text file. We're going to treat it as a config file, and then oftentimes it will then, especially if there's local modifications, decide not to upgrade it, instead just put it as dpkg new. Have you found a way to disable that behavior and say this is not a config file, treat this as code and always override it?
Yeah, you can, this Debian helper which build up the package, you can override things with that. So we override this magic from the Debian. We just say, just put it there, install the file and let it done. So yeah, but it's kind of a hack.
Okay, any more? Looking around. Well, Joran, that was an incredibly competent and detailed tour of Ansible. And bizarrely enough, I'd never come across Ansible. I've never used it before. So that was actually quite useful.
Yeah, you should just try. I have some colleagues just putting their dot files from Debian to all of the servers, so the bash RC or the vimrc, using Ansible because it's just more efficient than SSH or SCTP or something like that. So even the basic tasks you perform on different servers you can do with Ansible.
Great. Okay, well, everybody, if you found that this talk was really useful to you, comment on that in the sked.com app to ensure that Joran gets a really good chance of getting the Geek of the Week prize. And with that, I think we'll probably close it down here. Lunch is next on the agenda. And remember, it's not outside as yesterday.